Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, the fuel cost per hour for running a ship is approximately 1/2 the cube of the speed measured in knots plus additional fixed costs of $216 per hour. And we have to find the most economical speed to run the ship for a 500 nautical mile trip. Assume that there are no major disturbances such as heavy tides or stormy seas. So we have to find the cheapest way for the ship to do this 500 nautical mile trip, and we have to find the speed at which the ship can do that trip in the uh, cheapest possible way. Now we are given the fuel cost per hour, which is based on the speed of the ship. So the first step is to write the function for the fuel cost. So for that we'll have to use a variable for the speed of the ship. So let's assume x represents the speed of the ship. So the fuel cost per hour function, so let's assume it's function f and x is equal to, so is approximately 1/2 the cube of the speed. So that means x cube over 2, because it's half the cube of speed plus $216. So this is the fuel cost per hour. Now in order to find the most economical speed, we have to find the speed at which the total cost is lowest. So for that, we'll have to find the cost for the ship to undertake a 500 nautical mile trip. So the next step is to find the time in which the ship will travel 500 nautical miles. And for that, we'll use the formula time equals distance over speed. Now we are given that the distance the ship has to travel is 500 nautical mile divided by the speed, which we assumed is x. So this is the expression for the time it'll take this ship to travel 500 nautical miles. Now the fuel cost function that we calculated is per hour, and if it takes the ship 500 over x hours, so the unit of time is hours, so then the total fuel cost for the entire trip will be, so let's assume its function c at x. So c at x would be f at x, which is the fuel cost per hour times time. So the fuel cost per hour times the time in hours. So now we can sub in the expressions for f at x and t. So f at x is equal to x cubed over 2 plus 216 times 500 over x. Now we can simplify this expression. So we can just move the 500 to the front of the expression because 500 is just a coefficient. So c at x equals 500 times x cubed over 2 plus 216 then times 1 over x. Now we can distribute 1 over x in the parentheses. So we can continue here. So CRX equals 500, and first we do x cube over 2 times 1 over x, and then plus 216 over x. So when we multiply 216 with 1 over x, we get 216 over x. Now we can simplify this expression by cancelling out one of the x's. So there are two x's left now in the numerator. So CX equals 500, then parentheses x squared over 2 plus 216 over x. So this is the cost function that represents the cost to undertake that 500 nautical mile trip. Now we have to find the speed at which this cost will be lowest. So for that we have to find the x values at which this function CRX makes valleys, and at that valleys, at those x values, the tangent will be horizontal, so the slope of the tangent will be 0. So we'll find the derivative of CRX and then set it equal to 0 to find those x values. So our first step is prime of CRX. Now in this function, the x is in the denominator in the second term in the parentheses. So before we find the derivative, we should move the x to the numerator, because that will make it easy to find the derivative of this function. So we get 216 x exponent -1. Now we can find the prime of CX, which is equal to 500 stays as it is because it's the coefficient of the function, and then in parentheses, now the derivative of x squared is equal to 2x, and the 2 in the denominator stays the same because it's just a constant, and then plus, now 216 is the coefficient of the term, so it stays as it is. And now we can use power rule to find the derivative of x exponent -1. So we move -1 to the front, and then we subtract 1 from the exponent. Now we can simplify. So prime of CRX equals 500. We get parentheses, so the 2's cancel each other out, so we just get x. And then 216 times -1 is -216. And then x exponent -2. Now we can set the derivative equal to 0, and we can move x exponent -2 to the denominator, because that will make the exponent positive. Now we have to solve for x. So first we divide both sides by 500 to get rid of 500 on the right side of the equation, and 0 over 500 is also equal to 0, so we get 0 equals x minus 216 over x squared. Now we can move this 216 over x squared to the left side of the equation, and that will make this term positive, so we get 216 over x squared equals x. And now we have to cross multiply the x squared, so we get 216 equals x cubed. Now we can apply cube root to both sides to isolate x. So the cube root and the cube cancel each other out on x, and the cube root of 216 is 6. So x is equal to 6, and the speed is knots. Now we should find the domain for this cost function. Now x here represents the speed, so we know x has to be greater than 0. X cannot be less than or equal to 0. X cannot be equal to 0 because the X is in the denominator in this cost function. So if we sub in X as 0, then the function becomes undefined. Now there is no upper limit for X because X can be any value, and we are not given any information that suggests that there is any upper limit to the value of X. Now we cannot sub in X as 0 to find the cost of the trip at X equals 0, because at X equals 0 the ship is not moving. So that means the valid answer for the speed of the ship at which the cost for the trip is minimum is X equals 6 knots. So that means we can summarize our answer as, so most economical speed is equal to 6 knots. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve this type of problem. So in this problem, you have to be very careful about what we need to find and how we can get the function from the given information. So here we are given the fuel cost per hour, and then we find the time it will take to undertake that 500 nautical mile trip, and then we multiply those two functions to get the cost function for this 500 nautical mile trip. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.